Hi, my name is Tanya Khokhlova. I'm from the University of Washington, and my talk today is entitled Chronic Effects of Cavitation-aided Gemcitabine Delivery to Pancreas Cancer on Tumor Microenvironment in KPC mouse model. Pancreas cancer is known to be extremely fibrotic, poorly perfused, and with very high interstitial pressure. All of this impedes the penetration of systemically administered chemotherapeutics or imaging contrast agents. In our prior studies, we have demonstrated that inertial cavitation induced by pulsed HIFU without contrast agents can successfully disrupt the fibrous tumor tissue and facilitate penetration and uptake of systemically administered drug. In that case, it was doxorubicin. That study was done in a genetically engineered pancreas cancer mouse model, KPC mouse, that is uniquely recapitulating human disease, including the fibrosis. The objective of this study was to evaluate the effects of a more clinically relevant regimen of pulsed HIFU combined with gemcitabine administered weekly to the same mouse model, and to evaluate the effects of this treatment on tumor progression and microenvironment. So the mice, KPC mice, were enrolled in the study when the tumor size reached 4 to 6 millimeters, and then they were treated weekly and followed at least twice weekly with ultrasound imaging until they reached the endpoint, which was either tumor volume doubling or tumor size reaching 1 centimeter. At the endpoint, the mice were euthanized, and the tumor tissue was collected for histology, immunohistochemistry, and gene expression profiling. There were two groups in the study. In one group, the mice were treated with pulsed HIFU followed by IP administration of gemcitabine, and the other group was treated by gemcitabine only. For pulsed HIFU treatment, we used Alpinian VIFU 2000 system and similar HIFU parameters as used in our prior studies. Briefly, we used short 1 millisecond pulses at fairly high output to ensure consistent inertial cavitation at the focus. Cavitation was monitored using PCD, and all of that was done under ultrasound treatment guidance. Immediately post HIFU treatment, the treated area of the tumor appeared mildly hypoechoic. It's worth noting here that in the majority of cases, not the entire tumor could be treated because it wasn't acoustically accessible due to bowel gas. The area of hypoechogenicity persisted throughout the observation period. However, the adjacent non-treated area continued to grow. The treated area was also apparent as disrupted tissue on subsequent histology. And as we can appreciate from those overall tumor growth curves, pulse HIFU treatment appreciably retarded the growth of the tumors only in a subset of mouse subjects, and survival was only modestly improved in pulsed HIFU group. However, it's worth noting that we didn't see any decline in body condition or metastasis on necropsy in either of the group, which indicates that maybe our endpoint criteria were too restrictive and we simply didn't observe the mice for long enough time to see tumor retardation. On immunohistochemistry, we saw CD8 T cell infiltration into all tumors, regardless of the group, which is consistent with human tumors as well. There was more infiltration in more differentiated areas of the tumors. The pulse HIFU treated area was not infiltrated in any of the subjects. However, the granzyme B staining was only enhanced in pulse HIFU treated group. It was enhanced immediately adjacent to and inside the treatment area. Interestingly, the areas of granzyme B stain did not co-locate with CD8 stained cells, which indicates that it was cells other than CD8 cells that produced granzyme B. According to gene expression analysis with nanostring immune profiling panel, 109 genes were differentially expressed in pulse HIFU treated group. And according to, as can be seen from this volcano plot, by and large, they were downregulated compared to gem-only group. And when we look closely, it's mostly the immune complement pathways that partner with tumor for growth and progression that were substantially downregulated, as well as genes that are associated with tumor chemoresistance downregulated as well. Gene sets that are associated with immunosuppression and pro-inflammatory milieu that allow tumor to progress were downregulated as well. In conclusion, while weekly pulse HIFU plus gemcitabine treatments did not appreciably retard tumor growth over the limited observation period, they clearly did result in changes in tumor microenvironment, resulting in reduction of immunosuppression and sensitizing the tumor to chemotherapy through reduction of chemoresistance. Thank you.